Okay, I think I'm good to go. Okay, so welcome to my talk. This is Perforating Performance, a presentation on profiling. I am a slave to alliteration when the possibility arises. So my name is Peter. I've worked, I've kind of bounced around a few different industries, and I kind of had a windy way towards video games. I once worked at Intel working on SSDs, writing firmware. Then I was picked up at CD Projekt Red over the course of COVID because they needed some help with Unreal Engine, I guess. And then I got recruited by the Coalition, where I'm working on Gears of War E-Day. Now, what am I here to talk about today? Well, performance. We've all heard that it's a bit of an issue. But it's really easy, isn't it? You just push the big red button that says optimize. This is kind of what gamers want us to do, and why don't we just do it? It's right next there. It's just right next to the button that says add multiplayer. But it's not so easy. We all know it's not so easy. So I'm going to give a bit of a step-by-step guide on how do we approach hitting performance goals with respect to shipping. So here's a step-by-step guide to performance. First thing you're going to want to do is define your performance goals. Second, you're going to want to define what kind of hardware goals you want your performance goals to run on. Then you're going to test, you're going to profile, then you really want to automate and share and collab. The last 2 points are kind of optional, but I'd rather they aren't. So, step 1, first you want to define your performance goals. So performance I'm going to define as a game's ability to run at stable and acceptable frame rates. So acceptable being whatever kind of frame rate you decide to choose. 30 FPS, 60 FPS, 144, 165 or higher. You kind of decide this for your product. It's a bit of a design feature. Stable means that some percentage of your frames actually run at or above the acceptable frame rate. In kind of the AAA space, we would have a huge document detailing out what are the acceptable frame rates, what are the what's the stability criteria. So, for example, something would be like no hitches, bigger than 100 milliseconds or something. Like I said, you design this for your product, it's a bit of a feature. Then, secondly, performance doesn't really mean anything if we're not talking on the same ground with respect to hardware. So, I primarily work in Unreal Engine. A lot of the industry works in Unreal Engine, and a lot of game developers work with a lot of different assets, such as Blender, video editing software, large image manipulation software, and game engines themselves are pretty heavy. So it's quite often that a game developer will have a real beefcake of a computer on one side, and then we ship it, and then some Steam user gets really mad because they're running the game on old laptop from grandma. So when defining some kind of hardware, I would really recommend you target some kind of mid-range PC. Just going on like Best Buy and searching for like what's a really popular laptop, or if you're already developing on a mid-range gaming laptop, it's a really good option. That's a really good target. And the Steam hardware survey is great. Steam hardware survey shows a really awesome breakdown of how much of your market, how wide of a net you're going to cast with your target hardware. And more recently, these have become much more popular. I can say that for a lot of cases, these Steam Decks, ROG Allies, Steam Legion Go's, if you have one of these, they actually represent a huge amount of the available market for the gaming. And of course, one thing I'm not listed here, but if you are so blessed that you have access to a console dev kit, then obviously that's your target hardware. Just remember to flip it into release mode instead of the dev kit mode. Next thing you want to do is test. Launch your game onto your target hardware, and if the game runs good, you might just be done. Just remember to do it again every once in a while, so that as you're developing your performance, you don't regress on performance in any way. But a lot of times, you'll test the game, and it might not exactly hit what you're expecting. And in this case, what you want to do is profile. So profiling, in software engineering, a profiler is a tool used to help you analyze the performance of your applications to improve poorly performing code. That's from the Microsoft Developer Network docs. But when in doubt, if something's not performing right, the first thing you want to do is reach for a profiler. So I'm going to play a video and give my voice a break. So this is going to be a walkthrough of Unreal Insights. This is a profiler that's available in Unreal Engine, and it's going to show kind of an interesting use case for it. Okay, so the audio is not working, so I'm going to full screen this and talk through it. I was afraid this was going to happen, but I am prepared. So right now in this scene, we're going to see a scene that is going to perform kind of badly for some for some reason that's maybe not entirely clear. So this is the scene. We got a bunch of cubes. We're going to start play. We're going to start play. Whoops. I can't use the keys to click forward through the video. So we're going to hit play, and we're going to see that this scene performs really badly. If anyone were to look at this scene, yeah, we're hitting like 15 milliseconds on the frame on the game thread, and we're hitting these huge hitches over time. If we were to hazard a guess as to why the scene is doing badly, just looking at it, it might be because, you might be tempted to think because, hey, there's like 1 million cubes in the scene. Actually 376 to be exact. So let's delete them and then see what the performance is. All right, cool. The performance got a lot better. We don't see any of those hitches anymore, and the game is running great. So if we bring back the cubes, performance is bad again. So clearly the cubes must be the culprit. But how can we be sure? Unreal Engine provides this thing called Unreal Insights. It's a profiling tool, and it allows you to see what happens on a breakdown of your game's tick in terms of how much time each object is taking. So I click this little button in the bottom right corner, and it opens up this insights trace. I'll just skip forward a little. And so this is Unreal Insights. It looks a little bit scary, but it's pretty easy to use. The top shows a histogram of all of the frames that have been running throughout the course of the engine. And it shows, and you can see the spikes are where your really large frames are. And so clicking in through it, we're just going to skip forward until we hit the actual, until we can zoom in on the problem frames. So this is a frame that's being taken, and we can see, I can see the resolution's pretty bad here, but we can see that each of those frames are about 16 milliseconds, and so that's really not great. We can see that the biggest single thing that's contributing to time here is this object here called ball counter C. This object is actually and as a matter of fact, the cubes don't even show up in this trace. So our earlier hypothesis about the cubes themselves being the cause of the bad frame rate is probably incorrect. So let's go take a look at, so we're going to come back to Unreal here, and then we're going to take a look at this ball counter C object and take a look at what it's doing in its blueprint. And we can see that from the profiler, it is the blueprint tick that's specifically causing all of our frame time. So I did it again. I just want to say bye. Sorry. So we come back here. We delete so we take a look at what the blueprint is doing, because we know it's the blueprint tick that's actually causing the performance issues. And we can see here a very terrible node in Unreal Engine called get all actors of class. It is a very poorly performing node. You basically never really want to use this node, at least not on tick. It's okay to kind of use it in construction. So what we're going to do then is, well, we're going to get rid of this object and then see if our performance, and see how it behaves. And yeah, our performance is buttery smooth. So by using a profiler, you're able to see what actually causes the performance issues within your engine. Now, Unreal Insights comes with your download of Unreal Engine, and it's available at that path. Unity also has a similar profiler. This profiler is just built straight into the editor. You press Control-7 to access it, or through that path there. And it basically shows the same thing as Unreal Insights. If you need more power to figure out exactly, like for example, to figure out exactly why that node is really bad, you'll want to use something called a system profiler. So these system profilers are like PIX, Superluminal, AMD UProf. These are kind of more big, heavy guns. They're not necessarily intended for game development, but rather for general software development. And they will tell you exactly what your CPU is doing every cycle. Downside is they don't know what assets. They don't know anything about assets. And lastly, what you want to do is automate. So Unreal Engine comes with a script called run UAT. By putting in this arcane path, you can, instead of going through the editor and clicking a bunch of buttons to get a build, you could put this into like maybe a scheduled job or like a Python script or something, and you can get a build every single day. And then you can run your builds directly from the command line just by using an arcane invocation like that, and that way you can automate your testing, both your builds and your testing, so you can repeat that profiling process that we just did over and over again every single day and make sure that you're staying on task. And lastly, with any kind of performance win, you want to share and automate. You want to share and collaborate, because behind every performance win, there's usually a really cool story, and I want to hear those kinds of stories. So if you have access to the internet, there's the forums, there's the Discord, there are various Discords. Unreal Slackers is a really helpful place, and a lot of Epic staff troll around that place as well. You can do a version of this talk, but for Unity or Godot. And you can send me your weird performance issues. Those are my contact information. Thank you. Q&A? All right, so I think we got a few minutes for Q&A here, if anybody's got any questions. Oh, sure thing. Yeah. You got a question over there? Are there any soft skill tips for performing about performance issues with the team that we have? Okay, so yeah, this is something that I think the studio I work at, the Coalition, does extremely well, is that we are extremely open about performance. A lot of the numbers and a lot of the, especially sharing traces, when we take a performance capture, having those traces are really awesome because you can actually give them to another person who doesn't even have your build of the game, but just has the profiler installed, and they can, even without even having access to your source code or your game or anything, they can just look at it. So when we're talking about performance, a lot of asynchronous communications happen, but also we will pull people into a room and just be like, I don't know what that is, but maybe this person does, and then we'll pull them into a room and take a look. So sharing collaboration, very important for performance. Any other questions?
When you're doing benchmarks, how do you actually do like real benchmark? You have to buy a PC with like that spec of hardware, or is there like a simulator you can actually run the game through?
Right. So the question was, when we're doing benchmarks, do we have to buy a PC with that kind of benchmark, or is there simulators that we can run it through? So typically, yes, you would want the actual hardware to be able to test and debug on. The reason is because it's very hard to, especially when dealing with a lot of weird performance issues, a lot of them are really not so intuitive. You may find cases where you remove like 100 memory allocations, but then it got slower somehow, and that's due to some really weird way that the cache lines are talking to each other. At least it's at the point where, like, if you're trying to scrape microseconds off of your game. But if you're not so serious about that, what I would recommend, and you know, money's tight, and you have a reasonable like dev PC, what you can do is actually just limit the core affinity on your computer. That sometimes helps, and while running the game in development or editor mode is usually a big performance hit to your game. And if you can hit if you're somehow able to hit 60 FPS for your game and everything's happy for you in editor, you might not really need to do any performance. Any other questions? I do not, but if you have weird problems, send them to me. I can take a look. One question over there. How do you know when to go down the dots rabbit hole or not? Dots being Unity ECS dots, right? Right. So I would say it's a design decision very early on that you would have to make. It is basically a decision to completely change the architecture of the engine. I think you have to be willing to get dirty with it. Last time I used dots, it was a lot of, it was a very experimental state and not so easy to use. So if you got to be willing to get your hands dirty, but I'd say for the most part, get your game working, and then when you hit performance issues and you realize, hey, there's a real wall here that we cannot deal with, and we might need to do something more drastic or change, then that might be a good time to evaluate different technologies like that. Are we good on time? Last question. Right. So I think I would go back to, I have thought about this, and when it comes to online, I would almost define it as adding a couple more lines to this acceptance criteria for your performance goals. So instead of just dealing with a stable frame rate and stable and acceptable frame rate now, you may have you might need, if you're Valorant, you might want 100% accept at stable frame rate. You want 0 hitches. But then you also have requirements now on network latency and network traffic level. So if you are sending way too much network traffic, your game's performance will suffer and people with poor internet won't be able to play. Or if you have too high latency, like too many commands require a full round trip from the server, you're going to have a degraded experience. So I'd say it's part of these goals when you're dealing with online. Cool. All right, thank you.